Dun, 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 dun. Today we're gonna learn about how p-values relate to confidence intervals. And this isn't necessarily a video that I used to put in the final review, but what I found is these kind of questions make great exam questions because the only way you can get them is if you really understand p-values and confidence intervals. And I also found that a lot of students couldn't do it. So this video hopefully will try to make it a lot easier. So we are going to survey Americans, and we're going to try to find out what proportion of the Americans can name all 4 countries of the UK. It's called the United Kingdom because 4 countries were combined into one country. So what I wanted was a hypothesis test, and notice the null and alternative. It's a not equals. So if we drew what the rejection region would look like, we'd see both the tails filled in. It kind of reminds you of the picture for a confidence interval. I told you these were very valuable questions on the final because they show you how confidence intervals and hypothesis tests relate. They're doing the same thing, especially when we use not equals, which I purposely use for these kinds of questions for that reason. So I wanted a p-value, but instead I got me a whole bunch of confidence intervals. That's a little bit of a problem there. And so now the question is, what can I say about the p-value? With a whole bunch of these confidence intervals, can I make some statement about what the p-value could be? Well, before I even start thinking about it, there is something I can say about the p-value. The p-value is, by definition, going to be somewhere between 0 and 1. So out of all infinite numbers, I have zeroed it down to this range, which is so far really completely helpless. So now let's look at this first confidence interval. The confidence level is 90%. That's like a corresponding alpha level of 10%. Now, if my alpha level was 10%, I could use that to compare with my p-value. I'm going to mark on here where 10% lands. Now, the question of interest is, could the proportion be 10%? Now, looking at this interval here, it's between 13 to 17%. Is 10% in that range? The answer is no, 10% is not in that range. So if someone came to you and said, I think the proportion be 10%, you would respond, no, I reject that claim. This means if you be doing a hypothesis test of 10%, you would reject that hypothesis test. How does a hypothesis test get rejected? It gets rejected when the p-value is smaller than alpha. This alpha is 10%. Our p-value is smaller than alpha. We just learned something about our p-value. We were going all the way from 0 to 1, but we don't need to anymore. The p-value is somewhere between 0 and 10%. Can we zoom in any further? Well, yes, let's look at the next confidence interval. Is 10% reasonable? The answer is no, because 10% again does not fit within this interval. And so we would reject with an alpha of 0.08. That tells us our p-value is smaller than 8%. So on this graph, I can take away my 10% and put in 8% and get marker all over my hand. For the next confidence interval, a 95% confidence interval means an alpha of 0.05. And again, we would reject because 10% does not land in this interval. That tells us our p-value is less than alpha of 0.05. And so I'm zooming in again, as 0.08 can become 0.05. Let's look at the last interval. At 98% confidence, that's like an alpha of 0.02. And so if someone came to you and said, is 10% reasonable? And your confidence interval went from 9% to 21%, you would say, I cannot say that 10% is unreasonable. Therefore, we fail to reject the 10% with this interval. That means our p-value is bigger than an alpha of 2%. That means I can zoom in more, but I'm going to zoom in now on the 0 side because I know that my p-value is bigger than 2%. So it's somewhere between this 2% and this 5%. So can I say what the p-value is to 4 decimal places? No, but I can tell you a range. What can I say about the p-value? I can say the p-value is between 2 and 5%. So even though I did not do a hypothesis test, I did confidence intervals. I can use those confidence intervals to tell me something about the p-value. Let's try going the other direction. My goal now is to make a 91% confidence interval for the proportion of Americans who can name all 4 countries within the UK. But instead of doing the confidence interval, I instead have done a hypothesis test. you'll notice we are testing the 10% with a not equals, which makes this a lot easier. But we used an alpha of 0.05 and our p-value was 0.03. Can I use this information to tell me whether 10% will be in the interval? Well, let's start by drawing a picture. Here's our curve with a rejection region here drawn in red. It's 5%, so 2.5% in each tail. Now the p-value was 3%, so each tail must have had 0.015 in each tail. And so I landed outside that 5%, which means I was further away from the mean. You should be comfortable with this picture. I landed somewhere like that, which gave me a p-value in this area there. So this middle region here is not the 5%. This would be 95%. So if I had a 95% confidence interval, the answer would be no, it does not land in the interval. But if I use a 91% confidence interval, it will shrink even tighter. So the value of 0.1 would not be in that interval. In fact, I can actually say a little bit more than that. If I had a 97% confidence interval, 97% matches the p-value. If I match this p-value at 97%, then in that confidence interval, 0.1 would be right on the edge. Anything smaller than 97%, it will not be in the interval. Anything larger than 97%, and it will be in the interval. So you can take p-values and talk about confidence intervals, and you can take confidence intervals and you can turn them into p-values. What you can't do is name all 4 countries of the UK, huh? Because this is an Irish accent. It's a trick. Ireland is not one of them. Now, I want you to pause. Don't pause the video. It's almost over. But now go take the teacher evaluation.